Over the past few days, you've been solving lots of different fraction division problems using lots of different strategies. Look at all these different problems you've solved. Today we're going to see, though, if we can come up with one strategy that works for all the problems. We're going to see if we can write an algorithm for fraction division. What's an algorithm? If you can't remember, you can use our CT posters to help you. Yeah, an algorithm is a systematic, step-by-step approach to a problem. So we're going to practice developing one today for fraction division. When have you used algorithms in your life outside of school? What kind of algorithms do you follow? Yeah, game directions, that's a great example. What about in math class? What kind of algorithms have we used? Yeah, we have quite a few of them, right? The recent ones were fraction addition algorithm, and we have a fraction multiplication algorithm. Okay, so let's practice thinking about how we would write down an algorithm using fraction multiplication. So we can think about this example to help us. So 2/3 times 3/4. If you were solving this problem, what's the first thing you would do? Yeah, okay, multiply the numerators. Why would you multiply the numerators? What does that tell you? Yeah, it gives you the numerator of the answer, right? We know that's true. We thought about it using those pans of brownies. We figured out why that's the case. So in this problem, we'd say 2 times 3 is 6. That's the numerator of our answer. Okay, what would you do next? Multiply the denominators to get the denominator of the answer, right. We use the brownie pans to think about that as well. So in this case, we'd say 3 times 4 is 12. That's the denominator of our answer. So we end up with 2/3 times 3/4 is equal to 6/12. Now when we're using algorithms, especially when we're writing our own, we need to stop and think sometimes, does my answer make sense? It's a way to make sure your algorithm's working the way you hope it does. So let's think about that. Does it make sense that the answer to 2/3 times 3/4 would be 6/12? Well, another way to think about this problem is 2/3 of 3/4, right? And we can think about that. If we start out with that 3/4, maybe we just write them separately like this. And we're thinking about 2/3 of that. So just 2 of these. So 2/4. So 2/4 is the same as 1/2. And 6/12 is the same as 1/2. So I think we're getting the same answer, right? So we used 2 different methods, got the same answer. Seems like our algorithm's working. Great, it's always good to check. So do you think this algorithm would work for other problems too? Could we use it to solve 1/8 times 5/3? I think so. What about 1 3/4 times 2 1/2? I'm not so sure. Our first step says to multiply the numerators to get the numerator of the answer, but if we just multiply 3 times 1, I'm not sure where that leaves us, what we should have done with that 1 and 2 in the whole number parts. So we might have to add some steps to our algorithm to make sure we can also use it for problems with mixed numbers. So one of the really useful things about algorithms is usually they're written so they work for a lot of different problems. But when you're writing them, it can be really challenging to, on your very first try, write an algorithm that's going to work for every single problem. So a good strategy might be to write an algorithm that works for some problems and then see if you can adjust it to work for more problems. That's something I want you to try out today. So as you're looking at all these different fraction division problems you solved, instead of trying to write an algorithm that works for all of them, maybe just think about which one of these problems were the easiest for me to solve. See if you can come up with some steps that you could use for an algorithm to solve those problems. And once you're convinced that's working, maybe try it on some harder problems and see if adding steps or adjusting your steps can help. Okay, so I'm going to give you some time to start thinking through your fraction division algorithms. We'll come back together in a little while to see how it went. So you've been working on developing a fraction division algorithm. Does anyone want to share anything they noticed or wondered as they were working? Yeah. Okay. Yeah. Oh, that's interesting. Okay, I think what I hear you saying is that you started out just thinking about one problem at a time to try to write steps. And you knew the first thing you did to solve 9/5 divided by 1/2, for example, was to multiply this 9 by this 2. So at first you were going to write that down, multiply 9 by 2, but then that didn't seem like a very useful step for any other problem, right? Yeah. So what did you do? Yeah, you looked at some other examples too. So you knew that in this problem, you circled the 5 and the 12 because that's what you multiplied first. And in this problem, you multiplied 3 by 4. So once you had multiple examples, it was easier to see that what you were actually doing was multiplying the numerator of the dividend by the denominator of the divisor. So that's more general language that's probably more useful for writing a step that can be used on other problems. It's a really great observation. Okay, so let's look at one of the fraction division algorithms one of the groups developed. We're going to test it out. So let's try it on the problem 5 divided by 1 1/2. So the first step says, rewrite whole numbers and mixed numbers as fractions. So what do we rewrite here? Yep, I agree. So 5 becomes 5 over 1, and 1 1/2 becomes 3/2. Okay? And then here's the second step. We have to think carefully. We are multiplying the numerator of the dividend by the denominator of the divisor to get the numerator of the answer. So in this case, we're saying 5 times 2 is 10. 10 is the numerator of our answer. And then step 3 says, multiply the denominator of the dividend by the numerator of the divisor to get the denominator of the answer. So in this case, we end up with 1 times 3 is the denominator of our answer. So we end up with an answer of 10/3. But just to make sure our algorithm's working like we hope, it's always good to check it. So can we think of a different way to think about this problem that would help us be sure we got a good answer? Is there a different strategy you could use to divide 5 by 1 1/2? Maybe make an estimate? So for example, if we think of the problem as how many 1 1/2 fit into 5, well, we know 3 1 1/2 together makes 4 1/2. So we can fit 3 of them in, plus a little bit more. So our answer should be a little bit more than 3. Does that make sense with 10/3? Yeah, I agree, because 10/3 is equal to 3 1/3, a little more than 3. So it seems like it makes sense. Good, it seems like the algorithm's working. Let's try it with one more. How about 5/6 divided by 1/12? The first step says rewrite whole numbers and mixed numbers as fractions. So what do we need to do? Nothing, right? So there aren't any whole numbers or mixed numbers. So this step doesn't apply. It's like when in the order of operations, we knew we didn't have to worry about that step with parentheses if there weren't any parentheses. So this step doesn't apply. We can skip it. Okay, then we multiply the numerator of the dividend by the denominator of the divisor to get the numerator of the answer. In this case, we end up with 5 times 12, 60 as the numerator of our answer. And then step 3 says, multiply the denominator of the dividend by the numerator of the divisor to get the denominator of the answer. So in this case, we have 6 times 1 is equal to 6. And our answer is 66. Okay, so let's think again just to make sure. Does that answer make sense? Doesn't make sense. And why? Yeah. Okay, so you're saying the answer is equal to 10? Because there's actually 10 groups of 6/6 in those 66ths. I agree. So does it make sense the answer is 10? Why? Okay, yeah, okay, so you're thinking about how many 12ths fit into that 5/6. So we can show 5/6, that's what's shaded at the top here. And then if we show 12s in the one at the bottom, we can see that 2 12ths are going to fit into each one of those shaded sixths. So we end up with 2, 4, 6, 8, 10 12ths fitting in there. So that means the answer is 10. Seems like our algorithm is working for us. That's great. But here's my last question. This is something I was thinking about. Why are we multiplying in order to divide? Seems a little strange, doesn't it? That we have to multiply to divide fractions? Wonder why that works. And I came up with one way of thinking about it I'm going to show you, okay? So we know that another strategy for dividing fractions is to change the fractions to have common denominators. And when we do that, we can just divide the numerators. That's a strategy we came up with in an earlier lesson. So what if we did that here? We start with 5/6 divided by 1/12. And one way to change them to have common denominators would be to multiply each fraction by a version of 1 that uses the denominator of the other fraction. So we would multiply 5/6 by 12/12 and multiply 1/12 by 6/6. And if we do that multiplication, we end up with 12 times 5 over 12 times 6 divided by 1 times 6 over 12 times 6. So I didn't do out the multiplication because this actually helps us see that they have common denominators without even worrying about what 12 times 6 is. Okay, we can still see that they're the same denominator even if we don't do that multiplication. So because we've got common denominators, we can just think about dividing those numerators. So let's just write the numerators. 12 times 5 divided by 1 times 6. And then we know that when there's a division sign like that, we can actually write that as a fraction. So we end up with 12 times 5 over 1 times 6, which is actually the same as what we had up here when we used our algorithm, except the 6 times 1 is in a little bit of a different order, but we know that's the same. So that's why our algorithm works. When you're using that algorithm you developed, you're actually just taking a shortcut. It's like finding common denominators and dividing, but taking a shortcut to get there. So if you ever forget what the fraction division algorithm is, you can always just go back to finding a common denominator and dividing. You're going to get the same answer, It's just going to take you a few more steps to get there.